So in our last class, we were doing a ECMP, but due to some technical issues, it was not working properly. Let me recall what is ECMP and how it works first. Assume you have, this is your firewall. This is connected to your internal LAN. And internet LAN is connected to some particular VLANs in your organization. Okay. It is connected to like VLAN 10, VLAN 20, and so on, whatever, how many VLANs you have and how many PCs you have. And over a WAN side, you have two ISPs, ISP1 and ISP2. It is connected to your firewall. This is your WAN 1, this is your WAN 2 link. Okay. Now you want to utilize both the links, both the ISP links in a load balancing method. Load balance your internet traffic to both the ISPs. So what we can do, we can configure two default routes. Gateway will be, one gateway will be ISP1 and the another gateway will be ISP2. Okay, and the cost of both the links will be similar. So what we can see in our firewall, when we check a routing table or a FIP table in a firewall, we will say that we have two routes for a internet. See, usually we write a default routes when we want all the traffic needs to go from that particular link. So we have two routes available for our internet in our FIP table in firewall. FIP is forwarding information base in firewall. We have two tables in a firewall now. So traffic will be load balancing in both the ISPs. So what type of load balancing it can do? It can do like a source IP based or source slash destination IP based or round robin or weighted, we call it. Weighted means where which link has more weight, like this is 100 mbps, this is 50 mbps, most of the traffic should go from this particular link. We can do that type of load balancing when we have a ECMP. So again we will try to configure a ECMP and we'll see how it is working. We'll figure out again. Okay, so let me go to a lab first. And so this was our yesterday's topology. Still it is similar. Let me see what is available now. Get router info, routing table all. So we have two static routes configured to ISP1 and ISP2. Now we have two loopback addresses on our branch, 100 or 100, 200 or 200. Let me try to ping execute. First I'll ping gateways of both the ISPs, 10.1.1.2. Okay, it is pinging. Now again I will ping another ISP, 10.2.1.2. Both ISPs pinging. Execute the ping option. This time ping will be, what is the options we have? Source will be like 10.1.1.1. Now when I give this particular command, execute ping option, and if I ping a particular address like 100.100, traffic will only go from port 2 from a firewall. This execute ping is only from a firewall. Rest all traffic will do a load balancing. Ping 192.168.100.100. Okay, it is pinging 200.200. Okay, from ISP1 we are able to ping 100.100 and 200.200. Now I will change a ping option to 2.1.1. Okay, now again I will try to ping 100.100. It is pinging 200.200. It is pinging. So there is no issue with the routing. Execute ping option, reset. Now nothing is option, ping reset is done. Now first let us check what type of load balancing it is doing. To check that particular thing, we have one command, diagnose system VD list. You will get like it is doing what type of VD list. If you do this particular command, you can see ECMP is happening based on source IP based. Okay, so one source will go to ISP1, one source should go to ISP2. Firewall will decide that particular load balancing be based on a algorithm configured. Okay, so now what we will do, 1 minute, hold on. Okay, on branch I will start a debug IP ICMP. So to find out from where the traffic is coming from ISP1 or ISP2. Okay, now let me open VLAN 5 PC, show IP. Let me check. Whenever we do restart VPC, we need to configure IP again to 168.10.10/24 192.168.10.254. Okay, okay, now show IP again. That's fine. Again, we'll configure a VLAN 20 also. Show IP, nothing is there. 192.168.20.20/24 192.168.20.254. Okay, yeah, that's all. Now let me see if I have a policies from LAN to WAN. See, traffic is coming from LAN zone and it will go to WAN zone to ISP. So we should have a firewall policies, or else traffic will be dropped at firewall level. Sorry. I hope everyone is able to hear my voice.
Yes, yes.
Okay,
Recording not doing, huh?
recording is happening.
Okay.
Yeah. Let me go to policy and object and let me check firewall policies. Okay, we have two policies, one from a branch 2 port and one from a ISP2 port. Okay, now let me ping from a VLAN 10, ping 192.168.100.100. There would be one timeout. Okay, ping came. Let me check on a branch. Ping came from 10.2.1.1. So it came from ISP1, ISP2, sorry. 2.1.1 is ISP2, port 3. Let me ping from another VLAN 20 PC, ping 192.168.100.100. Request timeout. Again it came. This time it came from what VLAN? This time it came from ISP1. You see, when we ping 100 or 100 first time, it came from ISP2, but this time it came from ISP1. Clear? So this type of load balancing happens. But see, this type of load balancing will be decided by firewall. We don't have any such control over this load balancing. Now I ping 200.200. It came from ISP2 again. Now let me ping again from this PC 200.200. If I ping from a VLAN 20 PC, traffic is coming from ISP1. If I ping from a VLAN 10 PC, traffic is coming from ISP2. So usually this happens when we have a equal cost load balancing. Now if I change on a firewall load balancing algorithm, what will happen? Let me show you how to do that. See, you can do this particular configuration from a CLI mode only. Right now the load balancing is happening based on source IP. Now we will do based on source and destination port. Okay, let me open a firewall config. See, if something is not working in your lab environment, don't get panic, because it works sometimes, it doesn't work sometimes in our labs, but in real time environment it works normally. Source slash destination IP based. Okay. Now, as per my assumption, when we ping from particular VLAN 10 to 100.100, traffic should go from one ISP, and 200.200 traffic should go from another ISP. Let me do it like first I will take a VLAN 10 PC. Before that, let me clear if I have any sessions or something. Then we'll again try again. Let's see. No sessions now. Okay. 40 view source. Nothing. Destination. Nothing. Policies. Okay. No sessions. Nothing now. We'll open a branch PC. Then we'll open a VLAN 10. I will ping 100.100. This traffic came from ISP 1. Okay. Now again I will ping 200.200. This traffic came from ISP 2. For one particular PC, if the destination is getting changed, it is going from different ISP. Similar thing we will verify from our VLAN 20 PC. Let me do it like VLAN 20, right? Okay. 100.100. It came from ISP 1. Now let me ping 200.200. It came from ISP 2. So this type of configurations, it is manually selected by Fortigate. We are not doing any such manipulations. See what is happening. Let me create one table for you. Suppose VLAN 10 PC, VLAN 20 PC. Okay. If VLAN 10 PC is pinging 100.100, it is taking which ISP? It is not clear, right? Let me do one thing. Hold on. Now suppose if we have like a source slash destination IP based load balancing. In this scenario, what is happening? ISP1, ISP2. If you are pinging 100, VLAN 10 is taking ISP1. If you are pinging 200, VLAN 10 is taking ISP2. And if you are pinging 100 or 100, VLAN 20 is taking ISP1, and VLAN 20 200 or 200 ISP2 is taking VLAN 20. So this type of things are happening. Or sometimes what happens, 100 is taken by VLAN 10 and VLAN 20. Suppose you are pinging like 100.100, VLAN 10 will be taken by ISP1, and VLAN 20 will also take ISP1 only. One particular destination is taken by one ISP, and 200.200 it will go by like VLAN 20 will go to VLAN 10 will go to ISP2, and VLAN 20 will also go to ISP2. So this type of things happens when you have like source and destination based. But when you have source, one particular source will always take one ISP only, and another particular source will take another ISP. Suppose if we add more source or more destination, what will happen? Let us see now. As of now, we have like one source and one destination. I will add another source to VLAN 10, and will verify which ISP it will take. Let me add it like gig 0/3. Let me see, gig 0/3 is part of which VLAN. show VLAN brief. 0/3 is part of VLAN 10. Okay, let me power on this. I will configure this VLAN 10 IP. 10.10 already used. I will configure 10.20. Before that, let me change again firewall config to only source based. So we can understand one source is taking what and one another source is taking what ISP. Sometimes it may take same ISP. Set to v4 ECMP mode. Source IP based. Okay. Now let me again open a branch. This time I'll ping from another PC 192.168.100.100. Request timeout. It came, replies came. This time it went from ISP1. Let me ping 200.200. Again this came from ISP1 only. 200.200 also came from ISP1. Now this was a part of VLAN 10. I will take another VLAN 10 PC. Then we'll figure out if what is happening. See previous if we ping it took ISP1. Let's see another VLAN 10 PC what it will take. Now this took ISP2. Both are from same VLAN, but it is taking different ISP, right? 200 also took ISP2. So that's that type of load balancing we can achieve when we have a ECMP routing available in our firewall. Okay. Any questions? Let me know, or else we'll move to next topic. Okay. So next topic will be our policy based routing. See till now firewall is deciding what destination it should go to which VLAN or 1 minute. Hold on. Yeah. So till now firewall is deciding what source was what destination it should go to which particular ISP. Suppose you have two links now, ISP1, ISP2. Okay. Now you have a firewall. Hold down. Let me change. You have a firewall connecting to ISP1 as well as ISP2. Okay. Now you have a LAN. VLAN 10, VLAN 20. Okay. Till now, if we have a ECMP, firewall was deciding what source should go from what ISP and what destination should go from what ISP. But when we have a PBR, PBR means policy based routing. We can configure policies in such a way, routing policies. This is not a security policy. This is routing policy. When we do routing, see in a normal routing, what we are doing, we are just giving a destination and we are giving a gateway, right? Suppose if you are doing a normal static route in a firewall, what options you are giving? Let me show you. Or you can check even in a routing table. Get the router info, routing table all. Okay. So what you are checking? You are giving only destination and you are giving a next hop or gateway. Let me show you in a GUI. If you go to route network and static routes, and if you try to create a new route, so what you are giving a destination first, then you are giving a gateway. Just click on this. Okay, so after the gateway, what is the exit interface of that particular gateway? So in normal routing scenario, you are giving this. But when we have a policy based routing, apart from destination, see, when we have a PBR, we have options like this particular source, this particular destination should always choose particular ISP, ISP1 or ISP2, whatever ISP we want. When we have like VLAN 10, if VLAN 10 is going to 100.100 or Google or whatever YouTube, it should always choose ISP1. And if a VLAN 10 is going to 200.200, it should always choose a ISP2. Okay, we can do this type of scenario, or you can configure in such a way that VLAN 10 should always choose ISP1, VLAN 10 should always choose ISP2, and whenever ISP1 is down, automatically all the traffic of VLAN 10 will go to ISP2. We don't need to do any such failover configurations. Okay, so what we will do in our lab scenario, let me show you. Any questions in policy based routing theory? See, in general policy, in general routing take place based on a destination, but in policy based routing take place based on source as well as destination. It will check source destination both things in policy based routing. So what we will do in our scenario, VLAN 10 subnet always choose ISP1, VLAN 20 subnet always choose ISP2. Okay, we will do this type of PBR routing, but make sure when you do a PBR, first routing should be available. If you don't have a normal routing available and you are configuring PBR, it will not work. Normal routing in my scenario, what I am saying, first you should have a routes available in a firewall, then you can do a policy based routing. Okay, okay, so let's configure a PBR based on our requirement. VLAN 10 subnet always ISP1, VLAN 20 subnet always ISP2. Okay, then I'll show you in packet debugs also how it is taking. What is our incoming interface? LAN. What is incoming subnet? 168.10.0/24. Okay, then we need to configure destination. As I told you, when we have a PBR, we'll remove this. When we have a PBR, we need to write source as well as the destination, right? But when we have a normal routing, we only configure destination and a gateway. Okay, let us configure a destination now. 192.168.100.100/32. We can add one more destination because all the VLAN 10 subnet should go from particular destination only. Or you can configure like all in this scenario. Let me choose it from addresses like all. I'll choose all means all the traffic will go from this particular destination. And protocol even I can choose, but I am choosing any as of now. Gateway will be 10.1.1.2. Okay. Then I will configure another PBR. Incoming interface LAN 4. Source is 192.168.20.20.20.0/24. Destination is also all. Whatever traffic is coming from particular VLAN, it should always choose one particular ISP. Then what would be a gateway? 10.2.1.2. That's a gateway, right? 10.2.1.2. Correct. Enable. Now we have two PBRs available. Let me select the outgoing interface as well. I did not select an outgoing interface, where we can select incoming interface, outgoing interface. It would be ISP2 for a VLAN 20. We are selecting VLAN 10 this is okay. So VLAN 10 will be ISP 1. Then VLAN 20 will be ISP 2. Okay, now we have a PBR configured. Now let me start a debug first. First we'll do a debug for VLAN 10 PCs. Diagnose debug flow filter address 192.168.10.10. First I'll do debug with this particular PC. Diagnose debug flow filter trace, sorry, flow trace start 100. Okay, this time we'll not check debugs on branch, we'll check directly on firewall and see how the traffic flow is happening. Let me ping 100.100. Okay, two pings are
Whereas
enough.
debug means what?
Debug means you can check traffic is hitting which policy, how the traffic flow is happening.
Okay.
Okay, packet capturing, a debug means a packet capturing and seeing what is happening in the firewall level. Okay, I did two pings, so we'll capture this in a notepad now and see if a recording is, yeah, happening. Now we got two pings. If you see starting message received from 10.10 and destination is 100.100. Message allocate a new policy. Match policy based routing. See, in a normal scenario, you will see like find a route, right? But this time before routing, if we are matching a policy based routing and routing ID is 1. Let me see what is a routing ID in policy based routing. You see, it is matching VLAN 10 is matching, router ID is 1. Okay. Then we'll find a route. As I told you, after the policy based routing, a routing should always be available or else traffic will start dropping or something. Okay, then we add whatever NAT we configured, normally how policy and all are available, normal scenarios. Just give me 1 minute, I'll come back. Okay, so that's how when the return traffic is coming, it is taken as normally, not as a policy based routes. Okay, then a new packet came again it went to policy based routing and it went out. Let me ping from like 10.20 now and we'll again do a packet capture, then we'll verify again. It should again hit a policy based routing and we should get the same result again. Let me ping like 220.20. 10.20 should be this PC IP, right? 10.20. Okay, ping 10 dot, sorry, 100.100. Two pings, oh sorry, I did not capture, but let me capture first. We captured 100 or 100, I'll capture 100 or 200 or 200 first now, then we'll go to another and we'll do again. We need to change some debugs, then we can figure out. As of now filtering is happening based on 100.10.10 IP only, not 100.100. Okay, now, sorry. Okay, now again traffic came from 10.10, destination is 200.200. Again if you see a debugs, policy routing happening and it is happening on ID 1, and again traffic came back, it's continuous happening, same process again. So let me change a filter now. Diagnose debug reset. Now I will debug from, instead of 10.10 I'll debug from 10.20. Okay, previously we were doing debug on 10.10, I'll do debug on 10.20 now. Okay, now let me ping again from 10.20 PC now. Yeah, see, till now traffic is going via port 2 only, and hitting a policy routing. Okay, now let me see again from VLAN VLAN 10 PC only, but different same destination. It should again go with the same ISP only, because our requirement was VLAN 10 should always go from ISP 1. Copied this. Let me paste it here. Now the traffic came from 10.20, same destination, new session allocate. As I told you, packet flow of a Fortigate. It is hitting now a policy based routing again. It is going to IS port 2 ISP 1. Okay. Now what we will do, we will check from VLAN 20 PC. Let me do a reset. Now this time traffic will go from 20.10. Okay. Okay. Now let me ping from a ISP VLAN 20 PC and we'll verify again. 100.100. What is this PC IP? Show IP. Okay, sorry, my bad. 20.20. Okay, let me ping again. Okay, we got two pings. That's enough for our capture. Okay, now let me open a new tab. Yeah, when we are getting a traffic from 20.20, it is hitting a policy based routing, but ID 2 this time, because as per our configuration, traffic for ISP2, traffic for VLAN 20 should always go via ISP2. So that's what our requirement, and we are achieving that particular requirement. Traffic to VLAN 20 is always going from ISP2 IP only. It is not going from ISP1. And what happens when we have ISP1 down? How the traffic flow happens? Let us see now. I'll do a continuous ping to 100.100. This traffic is always, VLAN 10 is always going from ISP1, right? Okay. Now what I'll do on a fire on our topology, I'll shut down this ISP and we'll verify again what is happening. RTO request timeout. What is happening on a firewall level, we'll see. Or we'll shut down a link and we'll verify again. Get the router info, routing table, all. As of now, we have two ISP, two links. So it is happening. Let me see. Let me remove this link. Then we'll see again. Okay. Because of a virtual, our lab environment, if we shut down this link, this firewall, but link is connected, firewall will think, yeah, this is active and it will send a traffic to particular link. But if I remove a link, traffic is going from one particular ISP now. It's like in a real environment, if you have one particular ISP down, traffic should go from another ISP. That's how it is happening. See, previously what was happening, even still we have a PBR configured. Previously VLAN 10 to 100.100, it was going from ISP1 link only. But as of now, this is down, this is not connected. All the traffic is going from ISP2. But when this comes up again, automatically traffic will start going from this ISP again. Let us bring this back again, then we'll verify. Port 2, Ethernet 0, okay. Okay, let me power this on. We'll see, wait. We'll wait for a couple of minutes for this to up and run. Okay. This time I shut down a link to verify how the traffic is going for this particular ISP now for a VLAN 20 PC. Okay. Now traffic received from 20 and going to 100 or 100. Allocated a new session, but there was no policy based matching happening because there was no route to ISP2 available as of now. You see, when we have both the links available, we get one more match which is matching policy routing ID. But when we don't have another ISP available, what is happening? There is no policy matching, policy route matching, only a route find and go to security policies. Okay. So any questions in a now you have something available in a cloud, Azure cloud. Suppose you have a FTP server in your Azure cloud. Okay. FTP generally works on TCP port and port number is 21. Now what you can do in a PBR configuration, source will be your VLAN 10 as well as a VLAN 20 PC. Okay. VLAN 10 and VLAN 20. You can configure multiple source and multiple destinations. And destination will be your Azure IP. And after a destination, you can select a TCP port 21 when you are doing a configuration. And suppose your ISP1 is like 100 Mbps, your ISP2 is like 40 Mbps or 50 Mbps. And this particular traffic should always get the best path. So you can choose this particular source as a ISP1. Now you have a scenario that you need to allow a YouTube in your environment, but YouTube is not much a requirement, but it should be available in your environment. See, YouTube will take most of the bandwidth in your environment. Most of the companies which are having a corporate, they will get like bandwidth issues. They will always complain like we are not getting proper bandwidth of ISP and all. So what you can do, this particular source and YouTube, it should only go from ISP2. It should not go from ISP1 until ISP2 is available. So your applications or production or everything will go from ISP1, and browsing, media streaming and all will go from ISP2. You can do this type of scenarios when we have a PBR available in Fortigate. Okay. See, PBR is not a Fortigate proprietary. You can do PBR in Cisco or Palo Alto, any firewall. Clear?
Yeah, yeah.
Okay. So the next topic will be VLAN interfaces in a Fortigate firewall. Suppose, see, usually the best practice is configure a VLANs or a VLAN routing on a L3 switch. But there is a scenario that you don't have any L3 switch, or there are some customers who doesn't purchase a L3 switch. They will get you get a bomb. You are working in like a system integration company or a deployment company. You get a bomb. In a bomb, you have firewall. You have couple of L2 switches, and you will get like customer is already having ISP available. Now the requirement is we have a LAN, and this particular LAN user should get a internet from a ISP, from a firewall. Okay, this will be traffic flow. LAN will connect to our firewall, firewall will connect to ISP. Not only one LAN, we have like three VLANs or two VLANs available in our environment. They will have two subnets available in their environment. So now what you can do in this type of scenario, if you don't have any L3 switch, you can configure sub interfaces. Sub interfaces, or we sometimes we call it a VLAN interface in a firewall, and this VLAN interface you can bind with a physical interface. So how your network will look like in a real time when you do this type of configurations? You have a firewall, You have ISP. It can be one ISP or two ISP, whatever it is. But if you have multiple ISPs, how you do ECMP and all, we already discussed, and it will be same for this scenario also. We are not going to do any ECMP or PBR in this scenario. Now we have like L2 switches. Okay, one L2 switch will be connected to second L2 switch, L2 switch, L2 switch. Now this L2 switch will be connected to firewall. Okay, this particular port, suppose it is a port 4 and it is whatever port 1. So on this port you are configuring a trunk port. This is ideal port, you don't need any configuration. Now this is connected to VLAN 10 and we have another VLAN 20. Okay, it is nothing like you can connect one switch to one VLAN. This switch can also have a VLAN 20. Okay, so this will be our connection now. Now what you need to do, as this particular switches doesn't support L3 interfaces, on this particular firewall we will configure two VLAN interfaces. Okay, VLAN 10 and VLAN 20 interface we will configure, and these both interfaces we will bind with port number 4. So how we will do this, let me show you. I should have this particular lab. Let me remove that. Let me show you what type of configuration I have on switch. It is simple CCNA configuration. If you have gone through CCNA classes, it is very simple configuration. First you check show VLANs, show VLAN brief. So we have VLAN 10 and VLAN 20. Now Ethernet 0/2 is connected to firewall. In our scenario, show running config interface Ethernet 0/2. We don't have any configuration as of now on this, so I'll configure this port as a trunk port. Then we will have like show running interface Ethernet 0/0. We don't have any configuration here. I'll configure this as a VLAN 10 and this as a VLAN 20. So as per our lab topology, the port which is going to firewall, it should be trunk port. This port should be access ports. This is VLAN 10, this is VLAN 20. Okay, let us do it now. As per our lab, Ethernet 0/2 is going to firewall. Config T interface Ethernet 0/2 switch port mode trunk. Okay, switch port trunk encapsulation dot 1q switch port mode trunk. Okay, then I will configure Ethernet 0/0. Till now we configured 0/2. Now I'll do 0/0 switch port mode access switch port access VLAN 10. Then I'll do it for the Ethernet 0/1 VLAN 20. Okay, I'll save this particular switch configuration, close it. Now let me start with the firewall now. Fresh configuration we'll do on a firewall. Config system interface, edit port 1, set mode static, set IP 10.0.0.223/24, set allow access HTTPS HTTP ping SSH and telnet. Okay, we just did a management interface configuration. So let me go to browser. Let me again, we should get the access of firewall, then we will start. Okay, Okay, so it was old thing, nothing is there. So now we have like port 1 configured, port 2 we don't have anything. As you see, port 2 is going to our LAN side, right? So we will configure, we don't need to touch anything on port 2. We'll do one new interface configuration, which is like a VLAN 10. Okay, alias will give like a VLAN 10 gateway. Interface, it will be part of which port? VLAN 20. As you remember, I told you we need to configure two VLAN interfaces, and we need to bind it with a physical interface. Correct? So that's what we are doing. But in our scenario, only the port number is changing. We are configuring new VLAN interface and we are binding it to physical interface. Then we'll give VLAN ID. That's all. Then we'll do it like IP address configuration 10.1/24. After this, we can enable a DSCP. If we want, we can enable, or we don't want, we it's normal. Okay, we enable a DSCP. Okay, that's all. I'll click it. Okay. Once you configure one particular VLAN, you see previously we did not had like on port 2 there was no plus symbol or anything. If you click port 2 now, it has like a VLAN gateway bind with this port 2 interface. Now we'll do it to port 3 also, one more VLAN, and bind it to port 2 again. VLAN 20 LAN zone. Then we'll do it like 192.168.20.1/24. Okay, I'll do a ping. Then I'll again enable a DSCP for here. Okay, rest all things, that's fine. Now we'll see again. Now we have two VLANs bind with a port 2. Let me open this particular PC and see if I get IPs from a Fortigate now. Before that, let me see on a Fortigate. If you go to dashboard and a network, if you go to DSCP, we don't have anything as of now. Let me configure this PC as a DSCP client IP DSCP. It will have a DORA process, and we should get a IP from firewall. Okay, we got one IP 10.20. Let me refresh. Yeah, we got one client available now. Let me minimize this. Okay, 10.20 we got from VLAN 10 gateway. Let me do it for another VLAN. IP DSCP again. Again, it will have a DORA. Then it should get some IP. Okay, it got 20.20. 1 minute. Hold on, some issue with the lab. Got disconnected. Wait. Okay, so yeah, as we were saying, we got IP from VLAN 20. Let us see now. We'll refresh. Now we have one client from VLAN 20 and one client from VLAN 10. But the thing when you do layer 3 configuration with the VLAN interfaces in a firewall, see usually what happens when you have a L3 switch and you do a VLAN interfaces configuration. You have a VLAN 10 as well as a VLAN 20. Okay. Now with L3 switch, VLAN 10 PC can communicate with VLAN 20 without any policies or anything, because this particular switch is doing a routing, and it is not having any security policies to configure when the traffic is between a subnets or between ports. Okay, but what happens in our firewall, when we have a firewall and with one particular port we have configured two sub interfaces, VLAN 10 and VLAN 20 now. Okay, so these two sub interfaces are having two subnets. This is having 10.0 subnet, this is having 20.0 subnet. Now if a 10.0 users, we are having like 10.2 IP and 20.2 IP. Okay, if 10.2 wants to communicate to 20.2, traffic will reach till his gateway. What is a gateway? 10.1, right? The destination source is a 10.20, destination is 20.20. First traffic will reach a gateway. Gateway is on a firewall. Firewall will check it is on different port or different sub interface, and we don't have a policies between sub interface to sub interface. Traffic will be dropped at a firewall level. So we need to do, when we have a sub interfaces and we want a LAN to LAN communication, we should have a policy between interfaces in a firewall. Let me show you how we can do. First we'll check if it is working fine, or if it's not working, what we need to do. Okay, first I'll ping a gateway. 10.1 is my gateway. I'm able to ping a gateway fine. Now I'll ping another PC. 20.2 it should be 20.2. Okay, I'm getting a request timeout, request timeout, request timeout. So now what I'll do, on a firewall I'll write a policy from a VLAN 20 to VLAN 10 to VLAN 20. Then we'll see how it works. VLAN 10, VLAN 20. Incoming interface is VLAN 10. Outgoing interface is VLAN 20. Okay. Source will be 192.168.10. There is no source for this. VLAN 10 addresses. Okay. Destination will be VLAN 20. Services all will give, and we don't need any natting or anything because everything is connected on firewall itself. All sessions. Okay. Now we have a policy. Now let me again try to ping from VLAN 10 20.2. Now you see I am getting a replies from VLAN 10. But still, see, one way communication we allowed. If we start pinging from 20.2, this is a 20.2 IP. If I ping from here, still the traffic will not come to, wait, 10.2. Still the traffic will be getting dropped at firewall level, because we have like if the source is VLAN 10 and destination is VLAN 20, we allowed traffic. But if the source is VLAN 20, we have not allowed traffic from a firewall level, right? Let me start a continuous ping. As soon as we write a policy, it should start working. Okay, I'll write a policy. This time VLAN 20 to VLAN 10. Okay, incoming interface will be VLAN 20, outgoing interface will be VLAN 10. Source is VLAN 20, destination is VLAN 10. Services all, allow all traffic. Okay, now we got like VLAN 20 to VLAN 10 also allowed. Now let's see, it should start working. Yeah, you see, till now we were getting request timeout, but after a policy it starts working. So better if you have a LT switch, I suggest to do it on inter-VLAN. Routing should always be on a L3 and only internet traffic. See what happens in some cases I saw in my experience. You have a big end firewall, some high end firewall. It is connected to some core switches. Okay. See, your core switch supports everything. All routing and everything will be supported by core switch, and you have a link. Usually in our environment, why do we have a firewall? We don't take a firewall for any routing or any L3 configurations. Firewall is taken to do security part. Security in a sense, any filtering, any IPS signatures blocking, any web filtering, URL filtering, application control, or anything like what we say DNS filtering, any security part and antivirus scanning, we take a firewall in our environment. So why do we give a firewall burden of all L3 routing, inter-VLAN routing and everything? So usually if I have a customer to deploy, what we should do, we should have all L3 routing on a core switch. Because suppose if you have one particular client sitting and you have some internal servers, AD server or ever whatever, usually your client will be part of client VLAN, your servers will be part of server VLAN, right? And you want server to client communication. If you have a L3 on a core switch, it can communicate directly without a traffic going on a firewall. But if you configure a firewall with the VLAN interfaces, now then the traffic should go from a client to firewall. Then firewall again need to do a policy check and it will go to a server. It is extra burden to a firewall, right? So better if you have a switch supporting a L3, you should do on core L3 switches. But how to do it on a firewall if you don't have that type of environment, I showed you just now. Let me know if you have any questions or anything.